12, Chapter 12, Part 2, Training Intensity. Chapter 12, Part 2, Training Intensity. Training intensity is one of the most important acute variables in an integrated training program. Training intensity is defined as an athlete's level of effort compared to their maximal effort. The specific training phase and athlete's training goal will determine the number of sets and repetitions for an exercise. Intensity is then determined by the numbers of sets and repetitions to be performed, determined by training goals. Training intensity for optimal stress is important to ensure adaptations occur and minimize risk of injury. The risk of percentages of 1 rep max is a common method for identifying and recommendation training loads. This method requires occasional testing of 1 rep max to allow for adjustments in relative intensity. The more fit an athlete is, the greater the intensity needed to promote optimal gains in muscular fitness. Endurance is best developed with a training intensity of 50 to 70% of 1 RM. Hypertrophy is best achieved by training with 70 to 85% of 1 RM. Maximum strength adaptations are accomplished by training intensities of 85 to 100% of 1 RM. Power adaptations are best attained with 30 to 45% of 1 RM when using conventional weight training, or approximately 10% of body weight when using medicine balls. Pro tip: for beginning athletes, lower intensities will result in significant gains in fitness. But over time, intensity must gradually increase to continue to promote adaptation. Intensity continuum. Stabilization, strength, endurance, 50 to 70%. Hypertrophy, intensity, 75 to 80%. Maximal strength, 85 to 100%. Power, 30 to 45%, or less than 10% of the body weight. Page 427. Training in an unstable environment, as seen in stabilization phase of the OPT model, increases the training intensity because it requires more motor unit recruitment and more energy expenditure per exercise, leading to development of neuromuscular efficiency. Changing other acute training variables, such as rest periods and tempo, also changes the relative training intensity at a given load and the relative intensity of the entire workout. Thus, intensity is a function of more than just external resistance. An integrated training program will focus on a holistic approach that leads to continued adaptation. Repetition tempos. Repetition tempos refer to the speed with which each repetition is performed. This is an important variable for achieving specific training objectives, such as endurance, hypertrophy, strength, and power. Those are the objectives. Movement occurs at different velocities to get the appropriate result from training. The appropriate speed of movement, slower tempo for endurance, and faster tempo for power, for the exercise based on the repetition tempo spectrum. Tempo continuum. Stabilization, strength, endurance, slow. 4, 2, 1. Tempo continuum. Stabilization, strength, endurance. 4, 2, 1. 4, 2, 1. Hypertrophy moderate. 2, 0, 2. 2, 0, 2. Maximal strength moderate. 2, 0, 2. Power fast and explosive. Rest interval is the time taken to recuperate between sets, exercises, or both, and can be a dramatic effect on the outcome of the training program. Each exercise requires energy and the primary type of energy used during training depends on the training phase, exercise intensity, and goal. Each exercise requires energy, and the primary type of energy used during training depends on the training phase, exercise intensity, and goal. Rest interval, stabilization, strength endurance, 30 to 60 seconds. Hypertrophy, 45 to 90 seconds. Maximal strength, 2 to 3 minutes. Power, 3 to 5 minutes. Power and maximal strength adaptations may require up to 10 minutes of rest between sets and exercise, depending on the athlete's level of fitness. Hypertrophic adaptations are maximized when the rest interval are decreased to 45 to 90 seconds between sets and exercises, but are of course dependent on the load being used. Stability and endurance adaptations are best achieved with 30 to 60 seconds of rest. Dynamic resistance training, as well as isometric training, can significantly reduce ATP and creatine phosphate supplies. The ability to replenish these supplies rapidly is crucial. By adjusting the rest interval, energy supplies can be regained according to the goal of the training program. Phosphagen recovery has a half time of about 20 to 30 seconds. Thus, rest intervals of 20 to 30 seconds will allow approximately 50% recovery of ATP CP. 40 seconds will allow approximately 75% recovery of ATP. 60 seconds will allow approximately 85 to 90% recovery of ATP. 3 minutes will allow approximately 100% recovery of ATP. The rest interval between sets determines to what extent the energy resources are replenished prior to the next set. The shorter the rest interval, the less ATP CP will be replenished, and consequently, less energy will be available for the next set, and more energy must be drawn from other sources. This can result in fatigue, which can lead to decreased neuromuscular control, force production, and stabilization by decreasing motor unit recruitment. Therefore, inadequate rest intervals decreases performance and may lead to excessive compensation and perhaps even injury. As the athlete advances, this can be used as means to increase the intensity of the workout and promote better adaptations, especially for stability, endurance, and hypertrophy. For the advanced athlete, extended recovery periods may be necessary if heavy weight is being used repetitively. The goal of the training program should establish the appropriate rest periods. There are several factors to consider when prescribing appropriate rest intervals. Page 12.8, table 12.8. Factors affecting rest interval program. Training experience, training intensity, tolerance of short rest periods, muscle mass, general fitness level, training goals, nutritional status, recoverability. Training volume is the total amount of work performed within a specified time period. One must plan and control training volume to prevent overtraining. Training volume definition: amount of physical training performed within a specific period of time period. Factors affect training volume program. Training phase. Goals, age, work capacity, factors affecting training volume program. Recoverability, nutritional status, injury history, level of fitness. For an athlete to achieve optimum results from an integrated training program, the program must provide them with the appropriate planned training volume over extended periods of time. Pursuant to the principle of progression, as an athlete becomes more highly trained, greater amounts of stress are needed to continue to promote adaptations. A gradual progression in daily, weekly, and monthly training volume is necessary for long-term athlete development. One of the most important training concepts to remember is that, due to the effect of fatigue on performance, volume is inversely related to intensity of short rest periods are utilized. Due to effect of fatigue on performance, volume is inversely related to intensity of short rest periods are utilized. Training at high volumes of high intensity for extended periods of time may create excessive fatigue and lead to overtraining or potential injury. For example, when working with loads exceeding 90% of an athlete's maximum, a workout may involve a total volume of 20 total repetitions, 4 sets of 3 to 5 repetitions per exercise. However, when working with loads of 60% of maximum, a workout may involve a volume of 36 to 60 total repetitions per exercise, 3 sets of 12 to 20 repetitions. The exception here is the beginning athlete who may only perform 12 to 25 total repetitions per exercise, 1 set of each exercise. The exception here is the beginning athlete who may only perform 12 to 25 total repetitions per exercise, 1 set of each exercise. The readiness of an athlete, training phase, and training goal dictate the optimal number of repetitions, while the number of sets, intensities, reps, tempo, and combination of these dictate the volume. Volume continuum, adaptation, sets times reps. Volume continuum, stabilization, strength, endurance, 36 to 75 repetitions per exercise. Hypertrophy, 27 to 36 repetitions exercise. Strength, 18 to 24 repetition. Power, 12 to 20 repetition an exercise. Science of periodization. Training volume adaptations. High volume, the adaptation. Increase muscle cross-sectional area. Improve blood lipid serum profile. Improve lean body mass. Decreased body fat. Increased metabolic rate. High volume, low intensity. That was that. Low volume, high intensity. Increase neuromuscular efficiency. Increased rate of force production. Increased motor unit recruitment. Increased rate coding. Increased motor unit synchronization. Training frequency refers to the number of training sessions performed over a given time period, usually a week. There is considerable debate concerning the adequate number of sessions per body part per week necessary for optimal results. The number of training sessions per week and per body part is determined by many factors, including training goals, age, general health, work capacity, nutritional status, recoverability, lifestyle, and other stressors. Research on training frequency indicates the optimum training frequency for improvements in strength is 2 to 3 training sessions per muscle group per week. Other research indicates that training at least 1 to 2 times a week is sufficient to maintain the physical, physiological, and performance improvements that were achieved during other phases of training. It should be noted that 5 to 7 training sessions per week may be performed as long as the sessions alter the stress placed on the body to avoid working the same muscle groups more than 2 to 3 times per week. Training status appears to influence tolerance of higher frequency training, but is highly affected by training volume and intensity. Training status appears to influence tolerance of higher frequency training, but is highly affected by training volume and intensity. Higher trained athletes may be able to perform higher volume and higher intense work efforts in each workout compared to lesser trained, but will require longer recovery periods between workouts, resulting in lower frequency. Sports performance professionals should monitor fatigue and soreness over time, allowing for the adjustment of the training frequency. Training frequency, training duration. Training duration has 2 prominent meanings: the time frame from the start of the workout to the finish of the workout, not including the warm-up or cool-down. The length of time, number of weeks spent in one phase of period of training. The training duration for a workout is a function of number of repetitions, number of sets, number of exercises, and the length of the rest intervals. The training duration for an entire phase of training is dictated by the athlete's level of physical ability, goal, and compliance to the program. Typically, a phase of training will last 4 weeks, as this is the amount of time it generally takes for the body to adapt to a given stimulus. Most adaptations to a stimulus will be realized within 4 weeks. Afterwards, the training stimulus will have to be raised to achieve further adaptations. Depending on the training status of the athlete, training duration that exceeds 60 to 90 minutes, excluding warm-up and cool-down, may be associated with rapidly declining energy levels for training. This causes alterations in hormonal and immune response that can have a negative effect on a training program and raise the risk of minor infections, especially upper respiratory infections. Exercise density, the combination of volume, rest intervals, and the length of training session combine to result in exercise density. This represents the amount of work done in a, page 432, given phase of training. Greater exercise density is more stressful than lower exercise density, presenting a greater challenge to the neuromuscular and cardiorespiratory systems. As athletes increase their overall fitness, higher exercise densities can be tolerated, but in the initial phase of training or retraining, sports performance professionals should be cautious with exercise density. To alter exercise density, one should increase, decrease rest intervals, increase or decrease session length, and or increase, decrease volume of training in a given time. If fatigue begins to hamper performance in a training session, decrease density of work by removing volume or increasing rest intervals for the remaining portion of the workout. Decrease density of work by removing volume or increasing rest intervals for the remaining portion of the workout.